Hi everyone, in this video we are going to solve problems about torque. I'm Ibrahim Mutawa and this is Mu Physics. Before we start with the problems, we need to remember and revise all the formulas we are going to use. First, torque, tau, equals F, the force, times L, the lever R. So if I'm looking for the force, it will be torque divided by L. And if we are looking for L, it equals torque divided by F. Also, torque equals F R sine theta. They are the same. L equals R sine theta, so instead of L we put R sine theta. If you are looking for F, it will be torque divided by R sine theta, and R equals torque divided by F sine theta, and finally if you are looking for theta, equals arc sine or sine to power -1 torque divided by F times R. Let's see the problems. Problem number 1. A bolt on a car engine must be tightened with a torque of 35 Newton times meters. So the given torque equals 35 newtons times meter. You use a 25 centimeter long wrench and pull the end of the wrench at an angle of 60 degrees. The length of the wrench, which is R, equals 25 centimeters or 0.25 meters. Theta equals 60 degrees. How long is the lever arm and how much force must you exert? So first, to find lever arm, it equals R sine theta, in this case R, which is 0.25 times sine 60, so L equals 0.22 meters. And to find the force, we said before that force equals torque divided by the lever arm, so it will so torque 35 newtons times meter divided by L, which is 0.22, equals 161.7 newtons. Problem number 2. A bolt on a car engine must be tightened with a torque of 35 newtons times meter. The same as the previous problem. You use a 25 centimeter long wrench and pull the end of the wrench at an angle of 90 degrees. So the angle in this case is 90 degrees to the handle of the wrench. How long is the lever arm and how much force you must exert? So the given are torque equals 35 newtons times meter, R equals 0.25 centimeters, theta equals 90 degrees. We learned before that if theta equals 90 degrees, in this case L equals R. So L, the lever R, equals 0.25 centimeters, because sine 90 equals 1. So R times sine 90 equals R. So the force you need to exert equals torque divided by R, which is 35 Newton times meter divided by 0.25. This equals 140 newtons. So when theta equals 60 degrees, the force we need to exert equals 161.7 newtons. And now when theta equals 90 degrees, the force needed to do the same torque is 140 newtons only. So we see if you push perpendicularly, it will decrease the amount of force you need to do the same torque. Let's see the next problem. Problem number 3. If a torque of 55 Newton times meter is required to turn a bolt and the largest force you can exert is 135 newtons, how long a lever arm must you use to turn the bolt? So torque equals 55 Newton times meter. F, the available force that we can use, is 135 newtons, and we are looking for L. So in this case, L equals torque divided by F, tau 55 divided by the force, which is 135 newtons. This equals 0.407 meters. Problem number 4. You have a 0.234 meters long wrench. Of course, this is going to be R equals 0.234 meters. A job requires a torque of 32.4 newtons times meter. So the torque tau equals 32.4 newton times meter, and you can exert a force F equals 232 newtons. What is the smallest angle with respect to the handle of the wrench at which you can pull on the wrench and get the job done? So in this case, theta equals sine minus 1 tau divided by F times R. So theta equals arc sine 32.4 divided by 232 times 0.234. The angle in this case equals 36.6 degrees. The other part of the problem, a friend can exert 275 newtons, which means a greater force. What is the smallest angle she can use to accomplish the job? So if her force is 275 newtons, what is the angle? F is inversely proportional with sine theta, which means when force increases, the angle will decrease. Okay, so theta in this case equals arc sine torque divided by Fr. So theta equals arc sine 32.4 divided by 275 times 0.234, and this equals 30.2 degrees. So when the force is 232, the angle was 36, and with increasing the force, the angle decreases to 30 degrees. Let's see the next problem. Problem number 5. You stand on a bicycle pedal as shown below. Your mass is 65 kilograms, so M equals 65 kilograms. If the pedal makes an angle of 35 degrees above the horizontal and the pedal is 18 centimeters from the center of the chain ring, so R equals 18 centimeters, which is 0.18 meters. How much torque would you exert? In this case, theta is not 35. The angle between R, so this represents R, and this is F. So this vector represents F, and this angle with the horizontal is 35 degrees. So here we have 35 degrees. So what about this angle that lies between F and R? So if we draw F like this, and this is the horizontal, and this is R, this is perpendicular. F is perpendicular to the horizontal, and this is 35 degrees, and this angle will be 90 minus 35 equals 55 degrees. So this is theta. Okay, theta equals 55 degrees. One more thing, the force in this case is your weight, so your weight equals M times G. So put this in your mind. So now let's find torque. Torque equals F R sine theta. F in this case is M times G. So instead of F I put mg, R sine theta. Let's plug in the numbers. M is 65 degrees, G is 9.8 times R, which is 0.18, times sine 55. So the torque in this case, if you do your calculations, it will be 94 newtons times meter. And this is how to solve problems about torque. Thank you for watching, and for more quizzes and videos, please visit our website. This is the link, and the link will be in the description too. Thank you.